In Algebra 2, we spent a lot of time talking about polynomial functions, one particular type of polynomial function being the quadratic equation. So when we learned polynomials, one of the things we talked about was something called the degree of a polynomial and the leading coefficient. The degree of the polynomial is just the largest exponent of any of the terms in the polynomial. And the leading coefficient is the coefficient in front of the term with the largest exponent. So in example 1a, if I want to find the degree of a cubed plus 6a plus 14, it's just 3, because 3 is the largest exponent. The leading coefficient is the coefficient of that term. Well, remember when you don't see a number in front, it's a 1. So the coefficient is 1. In B, 5m squared plus 8m to the 5th minus 2. There are 3 terms, but the one with the biggest exponent is the middle one. So the degree must be 5, and its coefficient is 8. In this next example, we want to determine whether each number is a root of the polynomial x cubed minus 5x squared minus 3x minus 18 equals 0. I forgot to write the 2 numbers. One of them is 5, and the other one is 6. A root is just a solution to a polynomial. It really is the same thing as a 0. So we sometimes use these 2 words interchangeably, a root or a 0. A solution to a polynomial is the location where the polynomial hits the x-axis. So we also use x-intercept. In Algebra 2, you should have learned that root, 0, solution, and x-intercept pretty much all mean the same thing. It means find the solution or the x-intercepts. Now, although we use root and 0 interchangeably, we usually say that we find the 0 of a function in the root of an equation. So since this is an equation, we're going to find the root. If it said f of x equals, we would be finding the zeros. To determine if a number is a root, we're going to plug it into the polynomial and find out, does the polynomial equal 0? So in the first one, 5 cubed minus 5 times 5 squared, minus 3 times 5, minus 18. This is 125 minus 125, minus 15, minus 18. And although these cancel, negative 15 minus 18 is negative 33. Since it didn't equal 0, it is not a 0 or a root of the polynomial. Let's try 6 instead. We're going to do 6 cubed minus 5 times 6 squared minus 3 times 6 minus 18. Now I'm doing this the long way, but you can always just plug this into your calculator verbatim and hit enter and it'll tell you the answer. 6 cubed is 216. Minus 5 times 36 is 180. Minus 18, minus 18. And 216 minus 180 minus 18 minus 18 is going to be 0, which means that it must be a root of the polynomial. In other words, if you were to graph this in y1 equals, and look at the graph, I claim to you that the graph would cross the x-axis or touch the x-axis at x equals 6. The fundamental theorem of algebra says that the largest exponent of a polynomial, which was the degree of the polynomial, tells you how many roots, real and complex, that a polynomial has. For example, if I give you this polynomial, x cubed plus 2x squared minus x plus 3. Since the largest exponent is 3, there will be 3 roots, or 3 zeros, or, well, not 3 zeros, but 3 roots or 3 solutions to this polynomial. The problem is not all the solutions are real numbers. Sometimes they're imaginary numbers. So we're going to go back and we'll discuss a little bit about imaginary numbers, but the nice thing about the imaginary or complex roots is that they always came in pairs. Complex roots were of the form a plus bi. And if a plus bi was a root of a polynomial, so was its conjugate, a minus bi. In this next problem, we're going to state the number of complex roots of each equation, and then we're going to find the roots. So in part A, x squared minus 14x plus 49, since the largest exponent is 2, there are 2 roots. It means there's 2 solutions that we're looking for. How do we find those solutions? Well, I'm going to go back and do this the old-fashioned way, which is to factor. What are the 2 numbers that multiply together to give you 49, but when you add those same 2 numbers, you get negative 14? It's going to be negative 7 and negative 7. And then I just have to do the zero product property to solve. Problem is, they're both going to give me the same solution. So x equals 7 is the solution. It's just there's 2 of them. There's a reason for that. It's called a double root. And I claim to you that if you graph this in the calculator, you're going to see the graph hit the x-axis at one location. Whenever a graph bounces off the x-axis, we call it a double root. It means that there are 2 solutions and they're the same answer. If all the solutions are real numbers, you can graph this in the calculator and look for where it hits the x-axis. The problem we run into is when there are imaginary answers. So if you would like to graph this in your calculator and see where it hits the x-axis, you may do so. But I'm going to do it the old-fashioned way, which is by factoring. I want you to notice that all 3 terms have a common factor of a. I'm going to factor that a out. So I'm left with a squared plus 2a minus 8. Now, I'm going to go back up here for a second. Because the largest exponent is 3, there are going to be 3 roots. So we're looking for 3 answers. So first I factored out an a, and I'm left with this trinomial that's easy to factor. What are the 2 numbers that multiply to give you negative 8? But when you add them, you get positive 2. They're oops, I should use a instead of x. It's going to be positive 4 and negative 2. So now I'll use the zero product property to solve for a. So my 3 solutions are 0, negative 4, and positive 2. And if you graph this on your calculator, you should see it hit the x-axis at 0, negative 4, and 2. But this isn't Algebra 2 anymore. This is pre-calculus, and so we're going to give you a little bit more difficult factoring. So t to the 4th minus 1. It's very similar to t squared minus 1. T squared minus 1, if I were to factor it, factored into t plus 1, t minus 1. So now let's work our way back this way. This was actually t to the 4th minus 1. It's going to factor into t squared plus 1, t squared minus 1. Now, remember, since it's a 4th degree polynomial, there are going to be 4 solutions. They're just not all real. If you were to graph this in your calculator, you would only see the graph hit the x-axis 2 times. So the other 2 answers must be imaginary. The easiest way to find them in this case is to factor this. So now I'm going to do the zero product property and set both of these factors equal to 0. So t squared is going to equal negative 1, and then I square root that, and the square root of negative 1 was our definition of I. And you have to put the little plus or minus symbol in front of the square root. So 2 of the answers are positive I and negative I. Then I'm going to solve the other equation. I'm going to add 1, and then I'm going to square root, but the square root of 1 is 1. So it's going to be t is equal to plus or minus 1. which are the two locations you would see the graph hit the x-axis if you were to graph it. So my four answers, 1, -1, I, -I. Now we're going to work backwards, where I give you the solutions, and we're going to write a polynomial of least degree for each set of roots. So I want to show you something. This is an aside. Let's say I gave you the equation x squared plus 6x plus 8. And we wanted to go factor and solve this. This would factor into x plus 2x plus 4. And the solutions would be x equals -2 and x equals -4. What if instead I want to work backwards to write the equation? If I know the solutions are x equals -5 and x equals 7, then the factors are going to be x plus 5 and x minus 7. Notice that all I did was move these numbers so that I had an equation equal to 0. Now these are my factors. So my factors are x plus 5 and x minus 7. So in order to continue working backwards in order to write the original equation, I'm going to FOIL. X squared minus 7x plus 5x minus 35. And then I combine my like terms. X squared minus 2x minus 35 is the polynomial whose solutions are -5 and 7. I'll never give you one this long on a test, but this is a good problem to do in notes. So what if I tell you that the four solutions are 6, 2i, -2i, I, and -I? There are 5 solutions, which means when I'm done with the problem, it's going to be a 5th degree polynomial. The only thing is that the equation I get will only hit the x-axis once, because the other 4 solutions are imaginary. Now, there is a process for dealing with the imaginary numbers, and I'm going to show you how this works. So here's my aside. Remember, if you have a plus b times a minus b, when you multiply these together, you're going to get a squared minus ab plus ab minus b squared, and I want you to notice these cancel, so you're left with a squared minus b squared. So I'm going to start with these two roots because they're conjugates. I'm going to start with x is equal to 2i and x is equal to -2i. So my factors are x minus 2i and x plus 2i. So now I'm going to write this as x minus 2i, x plus 2i. Well, now this is very similar to this product of a sum and difference. When I FOIL this, the middle terms will be opposites and they'll cancel. It's x squared plus 2ix minus 2ix minus 4i squared. These cancel. In Algebra 2, we learned that I squared, by definition, is a real number. It's -1. So I'm going to replace the I squared with -1. And x squared minus 4 times -1 is going to be x squared plus 4. So that's part of my answer when I deal with 2i and -2i. Now let's deal with I and -I, because those two complex conjugates are going to FOIL into this difference of two squares, and you're going to get something very similar to what we got with 2i and -2i. So one of the solutions is x equals I, the other one's x equals -I. So the factors are x minus I and x plus I. Now I'm going to multiply these together. But since they are the product of a sum and difference, I'm going to start skipping steps. It's going to be x squared minus I squared, because the middle terms cancel. Remember, this is the only case where that's going to happen. And we just said that I squared is the same as -1. So I'm going to get x squared plus 1. And that's my next factor. I'm not done with this problem because there's still a 6. So x equals 6 is another solution, so x minus 6 is the factor. I now need to multiply these three together. X minus 6, x squared plus 4, and x squared plus 1. In order to multiply them together, I'm going to do this 2 parentheses at a time. So I'm going to start with these two. I'm going to get x to the 4th plus x squared plus 4x squared plus 4. And I've done nothing with x minus 6 yet. These are like terms, so I'm going to combine them. I'm going to get x to the 4th plus 5x squared plus 4. Now I have to distribute one more time because I still have that x minus 6. I get x to the 5th plus 5x cubed plus 4x minus 6x to the 4th minus 30x squared minus 24. And this always looks nicer if we write it in descending order of powers. So I'm going to write it as x to the 5th minus 6x to the 4th plus 5x cubed minus 30x squared plus 4x minus 24 equals 0. If you want to check to make sure you did the math right, when you graph this equation, the only place the graph should hit the x-axis is at x equals 6. The last problem we're going to talk about is a cylinder inscribed in a sphere with a radius of 6 units shown in the picture. We want to write a function that models the volume of the cylinder in terms of x. And the formula for the volume of a cylinder is pi r squared h. So, in order to write a polynomial for this particular function, my volume is going to be equal to pi and then whatever r squared is times whatever h is. Well, up here in the triangle, this is going to be a right triangle. And whenever you have right triangles, you can use the Pythagorean theorem in order to solve for one of the sides. Well, we want to know what r is. Actually, we want to know what r squared is. The Pythagorean theorem is a squared plus b squared equals c squared. X squared plus r squared equals 6 squared, because 6 is the hypotenuse of that triangle. So if I solve this for r squared by subtracting x squared, I find out that r squared is 36 minus x squared. I don't even have to square root it because I don't want to know what r is. I want to know what r squared is. So there's r squared. To find the height of the cylinder, well, this is the center of the cylinder. So if this is h, then x, the length from the center down to the bottom of the cylinder must also be x. So the height must be 2x. The next thing we're going to do is we're going to write this function as a polynomial function. In other words, we're going to multiply it out. The easiest way to multiply it out is to first distribute this. So 36 times 2 is 72x minus 2x to the 3rd. Now I'm going to distribute the pi. There we go. So the volume is going to be 72x pi minus 2x cubed pi. And that would be the polynomial. It's a polynomial of degree 3. Now the last thing we're going to do is we're going to find the volume of the cylinder if x equals 4. So we're going to plug in 4 everywhere we see an x. So 72 times 4 times pi minus 2 times 4 cubed times pi. I would recommend you not use 3.14 as the equivalent for the volume. There is a button on your calculator that will do pi for you to I don't know how many digits, so the answer will be more exact. The pi function is second And this is called the caret key. It's right under clear, and you'll see a little pi above it. Please use that button. So when you plug this into your calculator and hit enter, you're going to get approximately 502.65. We don't know the units of measurement, so we're just going to say it's in units cubed. All volume is in units cubed. And that is polynomial functions.